Hi everyone, my name is Emma Hacker and I am doing my e-presentation on plyometric training. So introduction, what are plyometrics? The word plyometric comes from two Greek roots, plyo meaning more and metric meaning measure. The term plyometric exercise refers to those activities that enable a muscle to reach maximal force in the shortest possible time. And according to Oxford Dictionary of Sports Studies, plyometrics is based on the proposition that stimulating a muscle stretch reflex can lead to a more powerful contraction and thus a greater training effect. So understanding plyometric exercise. Plyometric exercise aids in functional movements and athletic success by improving muscular force and speed. However, in order to use plyometric training effectively, one must understand three important factors. 1, the mechanics and physiology of plyometric exercise. 2, the principles of plyometric training program design. And 3, methods of safely and effectively performing specific plyometric exercises. So, the mechanics and physiology of plyometrics. When used properly, plyometric exercises have proven to improve one's production of muscle force and power. There are two proposed models on how plyometric exercise improves the production of muscle power. They are called the mechanical model of plyometric exercise and the neurophysiological model of plyometric exercise. So, starting with the mechanical model, this model proposes that elastic energy and musculotendinous components increases with a rapid stretch and then is stored. When this is followed by an action from the concentric muscle, that stored energy is then released and therefore increases the total force production. The workhorse of this model is a series elastic component, otherwise known as the SEC. During an eccentric action, the SEC stretches while elastic energy is stored. When followed by a concentric action, and while the elastic energy is released, the SEC contributes to total force production as muscles and tendons return to their unstretched formations. This model also proposes that if the eccentric phase is too long or is not followed by a concentric action, the stored elastic energy dissipates and is therefore lost as heat. Next, with the neurophysiological model. This model involves potentiation of the concentric muscle action that is caused by the stretch reflex. That's a lot of complicated words, so let's break it down. Potentiation is the change in force velocity characteristics of the muscle's contractile components caused by stretch. The stretch reflex is defined in our textbook as the body's involuntary response to an external stimulus that stretches the muscle. In this model, a rapid stretch stimulates muscle spindles and results in a reflexive muscle action. This action causes potentiation and increases the activity in the agonist muscle, resulting in an increase in total force production. According to the model, if a concentric action does not immediately follow the stretch, the ability of the stretch reflex is then negated. So, scientific data. Both models seem to contribute to the increased force production that results from plyometric exercise. However, the extent to which each model contributes is unknown and requires further investigation and research before determining the roles of each model in plyometric exercise. So now plyometric program design. There's very little research on optimal plyometric exercise programs, making it slightly more difficult when designing a plyometric exercise program. Professionals mainly rely on the work of Donald A. Chu and information from the National Strength and Conditioning Association. Similar to creating a resistance training program like we did for our project, a plyometric program design relies on specific variables, such as the needs analysis, which is the needs of the athlete, mode, which body region is performing the given exercise, intensity, which is the amount of stress characterized as high, medium, or low, frequency, the number of plyometric trainings per week, recovery, amount of rest between reps and sets, volume, the number of contacts in each session, and program length, how long the program lasts. Optimal program length has not been determined. So in the book High Power Plyometrics by James C. Radcliffe, he creates an equation for how to calculate power in a plyometric exercise. And so here it is. And I broke it down. The P is power, force is force application or strength and impulse. D means distance transition or agility and coordination, and time is time reduction or speed and acceleration. So here's a sample program that I made for a client who's a beginner when it comes to plyometric exercise and is hoping to improve lower body power. So the needs of the client is to improve lower body power. The mode is their lower body. Frequency is about 2 to 3 times per week. Since they're a beginner, their volume is 80 to 100 contacts, and then the program length is about 8 weeks. To the right is a second table that I made, which would be probably one of the first plyometric sessions that they do. It has 6 exercises ranging from low to medium intensity and a total of 80 contacts. So safety considerations while performing plyometric exercises. Plyometric exercises are not dangerous. However, there is still a risk of injury. Common injuries in plyometric exercises result from errors such as improper training procedures, insufficient warm-up, poor shoes or surface, and simply just a lack of skill. It is essential to demonstrate proper technique and take the athlete's physical characteristics such as strength, balance, and weight into consideration when forming a plyometric exercise program. So, dangers of injury with plyometric exercise. Due to little information on plyometrics, I was unable to find if there's any information on the consequences of chronic or overuse injuries associated with plyometric exercise. However, there has been research that suggests that the use of improper volume or intensities for a specific phase of training can lead to injury. This means that if an individual is performing an exercise that is too intense or results in a number of contacts that are too great for their current status with plyometric exercises, an injury can occur. So in conclusion, plyometric exercises are an ever-growing way to improve the status of an athlete's speed, force, and power. However, there is little research on plyometric training which makes it easy for someone to injure themselves due to improper technique or understanding of plyometric exercise. When participating in plyometric training, it is important to start slow, use proper technique, and to understand what your body is capable of. When used properly, plyometrics are known to significantly improve an athlete's abilities and therefore are incredibly valuable to athletic performance. To end, I have some quick questions so go back and watch the video. What is plyometric exercise? Which model of plyometric exercise contributes most to improvement in total force production? And what are some variables that contribute to plyometric program design? If you all have any questions for me, you can comment under this video and I will get back to you, or you can message me on Canvas. Thanks. Have a great day.